9, Section 4, Special Right Triangles. The special right triangles are right triangles with angles measuring 45, 45, 90 and 30, 60, 90 degrees. For a 45, 45, 90 triangle, in a 45, 45, 90 triangle, the hypotenuse is going to be the square root of 2 times as long as each leg. So if I drew a 45, 45, 90 triangle, I would label each leg as x, and then the hypotenuse of that triangle would be x times the square root of 2. The first example of this says find the value of x. Notice this would be a 45, 45, 90 triangle because they tell us that we have a right angle and that one of the angles is 45 degrees. By the third angle theorem, we would know that the third angle would also be 45 degrees. Notice that they've told us that both of the legs are 5. They've gone ahead and they've labeled that for us, and they want us to find x, which would be the hypotenuse. Based on what we just talked about in the theorem, we would take the leg length, which is 5, and we would multiply that by the square root of 2. So the length of x would be 5 square roots of 2. For the 45, 45, 90 triangles and the 30, 60, 90 triangles, I want you to go ahead and leave it in radical form or leave it with a square root in your answer for today, or for this lesson. This next example asks us to find the value of x. Notice again we have a 45, 45, 90 triangle, but in this case, x is going to be the length of the legs and 12 would be the length of the hypotenuse. What we're going to do in this situation is we are going to take x and we are going to multiply that by the square root of 2, and we know that that would be equal to 12 because the square root of 2 times x is equal to the hypotenuse. What we need to do to solve for x now is we need to divide both sides by the square root of 2, which would leave us with x equals 12 divided by the square root of 2. If you remember in Algebra 1, you talked about radical rules. We do not want a radical in the denominator. Take a second and think about, do you remember how to get a radical out of the denominator or out from the bottom of a fraction? What you can do is we can take, in this case, 12 square roots of 2, and we can multiply that by the square root of 2 over the square root of 2. Multiplying something by the square root of 2 over the square root of 2 would be the same thing as multiplying it by 1. And when we multiply a number by 1, remember that it just remains itself. But when we multiply straight across, we would have 12 times the square root of 2, which would just be 12 square roots of 2. But in the denominator, we would have the square root of 2 times the square root of 2, which the square roots, it would be like the square root of 2 squared, which will leave you with just 2 in the denominator. Now we can simplify this even more. 12, we can combine our whole numbers. We can combine 12 and divided by 2, which will give us 6 square roots of 2 for our final answer. In a 30, 60, 90 triangle, the hypotenuse is going to be twice as long as the shorter leg, and the longer leg is going to be the square root of 3 times as long as the shorter leg. So in this case, when I drew my 30, 60, 90 triangle, the side opposite of my 30-degree angle would be my shortest leg, and we could name that x. The side opposite my 60-degree angle would be my longer leg, which we could label the square root of 3 times x. And then the hypotenuse, which would be opposite the 90-degree angle, would be 2 times x. In all three of these cases, x would be the length of the shorter leg. This example asks us to find the value of f and g. Notice that we do have a 30, 60, 90 triangle. 18 would be the longer leg's length. F is going to represent the shorter leg's length, and then g would be the hypotenuse. In the theorem, we need to know the shorter leg before we can find the hypotenuse, so I need to solve for f first. We just said that the longer leg is going to be the square root of 3 times as long as the shorter leg. So when I know the longer leg and I want to find the shorter leg, I can say that the square root of 3 times x, x would be the measure of side f, equals 18. Now what I need to do to both sides is divide it by the square root of 3. So I'd have 18 divided by the square root of 3. Just like in the last example, I need to go ahead and get rid of the radical on the bottom by multiplying both the top and the bottom by the square root of 3. When I do that, my square roots cancel out in the denominator. I'm left with 18 square roots of 3 divided by 3. And now I can divide 18 divided by 3, which will give you 6 square roots of 3 would be f. Now that I know the side length of the shorter leg, I can use that to find the hypotenuse. I know that I need to take the shorter leg length, which is 6 square roots of 3, what I just found, and multiply that by 2 to find the denominator, or to find the hypotenuse, I'm sorry. Now when I multiply 2 times 6 square roots of 3, I'm going to go ahead and multiply my whole numbers. So multiply 2 times 6, which would give you 12 square roots of 3 for side G. The next example says a ramp is used to unload trucks. How high is the end of a 50-foot ramp when it is tipped by a 30-degree angle and then by a 45-degree angle? I'm going to go ahead and I'm going to draw myself a picture. They told us that I had a ramp, which would be represented in yellow here, that's 50 feet long. And then they also tell me that we're going to have a 30-degree angle for the first triangle. And I want to find how tall it would be. So that would be that solid white line, which I've just marked X. Notice that X would be the length of the shorter leg. The hypotenuse of this right triangle would be 50. So what I can do is I can take the hypotenuse and set that equal to 2x. When I divide both sides by 2, I would find that x equals 25. So when the ramp is tipped at a 30-degree angle, it's going to be 25 feet off the ground. And then they also asked me to how high it would be after it was tipped by a 45-degree angle. So I'm going to draw myself a picture again. That triangle is not very accurate. It should be a little bit, the legs should be the same length, but this will work. We know we have a 45, 45, 90. I'm still trying to find that that leg length. In this case, I can say that 50, the hypotenuse, equals the square root of 2 times x, which would be the square root of 2 times the length of the legs. Go ahead and divide both sides by the square root of 2. Again, we can't have a radical in the denominator, so I'm going to multiply by the square root of 2 over the square root of 2, which will give you 50 square roots of 2 over 2. Go ahead and divide 50 by 2, and you get 25 square roots of 2 would be the distance from the ground for the 45-degree angle. This last example says the roof of on a doghouse is shaped like an equilateral triangle with a height 3 feet. Estimate the area of the cross-section of the roof. If you notice, when I put the height in here, and they tell me it's 3 feet, it creates a right angle. We started with an equilateral triangle, which means all 3 angles of the larger white triangle would measure 60 degrees. When we bring the height, or that red dotted line, down, that's going to bisect my top angle, so this angle would be 30. So notice when I draw in my height, I've created a 60, 90 triangle. I know that the height of this triangle is 3 feet. I want to find the area of the whole white triangle. In order to do that, I need to find the length of the base. What I'm going to do, and there's another way that you can do this, but for right now, I'm going to find the length of the shorter side x. But if you notice on the bottom, that would only be half of our base. So once I solve for x, I'm going to actually have to multiply that by 2 to get the length of the entire equilateral triangle. So to solve for x, I'm going to use the fact that it's a 30, 60, 90 special right triangle. I know that the longer leg is 3 feet. When I know that the longer leg is 3 feet, I would multiply the square root of 3 times x, which would be the shorter leg, and set that equal to 3. I need to divide by the square root of 3 on both sides. When I do that, I need to multiply by the square root of 3 over the square root of 3, which would give me 3 square roots of 3 over 3. My 3's are going to cancel out in my numerator and denominator, so the length of x would be the square root of 3. But remember, that's only half of the base of the equilateral triangle, so the length of the whole side would be 2 square roots of 3. Now they asked me to find the area. Remember, the area of a triangle is 1/2 base times height. So I would have 1/2 the square root of 2 square roots of 3 times 3. When I multiply that all out, I get the square root of 3 times 3, which is just going to be 3 square roots of 3 feet squared for the area of the cross-section of the equilateral triangle roof. Today's assignment is on page 554. It's numbers 3 through 26, number 37, and number 38.